Greetings. In this video, I'm going to demonstrate how to get a lot of the data that people need for method sections of social scientific manuscripts. It corresponds to the second lab that I have my class do in Quant 2, and so I'm really recording this so that they have a guide to see the how-to on the lab, but I thought it could be interesting for anybody that wanted to watch it. So, we're primarily going to be getting Cronbach's alpha, means, standard deviations, and percentages. But the first question on the lab just asks how many participants were there. And I should say that I am using a version of this data that I have already dealt with all of the missing data problems associated with it, and I posted a 3-video series describing all of the steps that I used in dealing with the missing data. And so a good way to find out how many units of analysis or participants you have in a data set is the nrow command. So the data set is named DEB or DEB because it's debate watch data, and there are 339 rows which correspond to participants in the debate watch data. So we have an N of 339 in this particular experimental study. Now, for the percentages and the number of people in various nominal or categorical variable categories, I'm going to use the janitor package because I like the table function in the janitor package more than the base R table function. I'm also using this option left paren digits equal 4 right paren. I'm using that command just to make it so that the length of the numbers reported past the decimal point are a little more pleasant. Now, the second question in the assignment was how many participants were in each debate watch, and this was the first debate between Donald Trump and Joe Biden and the second and final debate between Donald Trump and Joe Biden, and the data set has people who viewed each of the two debates. And so if we use the tabyl function from janitor, which is janitor's table, it shows, so it's tabyl left paren, the name of the data frame, which is DEB, $, and then the name of the variable. And in the data set, the variable is named debate, and then right parenthesis. So it's just the table function, and then in parentheses, the name of your data set, $, the name of your variable. Close parentheses. And here it says in the first debate there were 171 participants, which is 50%, it's actually 50.44% of the data set. And in the third debate there are 168 participants, which is 49.56% of the data set. So you get the number of participants and the percentage using the table function, which is why I prefer it to the base R function. Okay, the third question was how many participants were in each chat condition. This experiment had people watch the debate over Zoom. You might remember that the 2020 debates happened during peak coronavirus, and so we couldn't have people come into classrooms to watch the debates, and so we had Zoom debate watches, and then we randomly assigned them to a control condition where they weren't allowed to chat, or a condition where they could chat with Democrats and Republicans, or a condition where only Democrats talked to each other, or a condition where only Republicans talked to each other. And so we can find out how many people were in each of these conditions using the same table function. And one thing that I'll point out that's odd about this is that we have 254 people have a 0, which means, so this is in the control condition. That means that 254 people weren't in the control condition. And 85 people have a score of 16. And that's peculiar. It's not peculiar that it's 85 people, which is 25% of the sample. That makes a lot of sense because there are 4 conditions, and so about 25% of the sample should be in each condition. It's just odd that the score they have is 16. We really want that to be a 1, indicating they were in the control condition. So the 16 could also say they are in the control condition. It doesn't have to be any particular number, but if we're going to use it as a dummy-coded variable in a regression model, we really need to change that 16 to a 1. So I don't know why the survey software recorded it as a 16, but it did. So then we do the table left paren deb $ mixed right paren, and that gives us 264 people, which is 77% of the sample, are not in the mixed condition, and 77 people are in the mixed condition. And again, the score it gave them is 16. And again, I don't know why the survey software recorded people in the mixed condition with a 16 instead of a 1, but we'll have to fix that. Okay, then in the DemCon, which is Democrats talking to Democrats, we have 247 people who are not in that condition, which is about 73% of the sample, and then 92 people, which is about 27% of the sample, were in that condition. And notice that the people who were in that condition were given a 4, so it was scored with a 4 in this instance, instead of a 16 or, again, like you would expect, like a 1. And we have the same thing for the Republican condition. So table, and then in parentheses, debate $repcon, and it gives us 269 people were not in the Republican condition, and 70 people were in the Republican condition, which is about 21% of the sample. You see after the 70, it gives you 0.2065, which rounds up to about 21%. And again, you see that it scores them with a 4, which again, I don't understand why it did that, but you know what? Let's go ahead and fix it and change those 16s and 4s into 1s. So in order to do this, we're going to use dplyr and I think tidyr. So I just recommend installing the tidyverse if you haven't, and then being sure you load the tidyverse. So install .packages, parentheses, quotation marks, tidyverse, and library, parentheses, quotation marks, tidyverse. Then to recode these, we're going to use dplyr, and so we're going to say deb equals deb, that's deb equals deb, and what that means is we're going to create a new data set called deb from the old data set called deb. So this is essentially just writing over, this is like when you save a Word file as you're working on it, you save it as the same name, but you're saving over the old version. Deb equals deb is just doing the same thing. Then we put a pipe, which is common to tidyverse syntax, which is the %, the greater than sign, and the %. And then the command is mutate underscore at. So mutate underscore at, left parentheses. And then we need to list all of the variables that we want to recode. And remember in R, when you list, you use C parentheses. And so we will do C parentheses, and then in quote marks, control, and then a comma outside of the quote marks. So left quote mark, the word control, and the C in control is capitalized. Right quote mark, comma, and then in quote marks the word mixed, and the M in mixed is capitalized, and then another comma, and then within quote marks, DemCon, and the D in dem is capitalized, and the the C in con is capitalized. So it's capital D-E-M, capital C-O-N. And then comma, quote marks, capital R-E-P, capital C-O-N. That's repcon. And then close the quote marks, close the parentheses from the list, add a comma after that, right paren. And then we need a tilde, which is the indication of the function we're running. And so tilde, and then the command name is recode. So tilde, R-E-C-O-D-E, and then another left paren. Then we need a dot, or a period, after that left paren. And the period is saying, apply this function to all of the things in the list above. So the period is how we say we want you to recode control, mixed, demcon, and repcon. And then a comma after the period. And here we need to put all of the numbers that it's going to encounter in these variables. So that's 4, because 4 is in repcon and demcon, but you need to put that in quote marks. I use single quote marks. I'm going to be honest with you. I don't know if R cares if it's single quotes or double quotes, and I'm using double quotes above in the C list, and I'm using single quotes down here in the recode, and I honestly can't tell you if it matters. Maybe somebody can comment in the video. It doesn't matter or it does matter. Anyway, after we go tilde, recode, left paren, period, comma, we do a upside down comma or a single quote mark, and then the number 4, and then close that quote mark, so a right quote mark, equals 1. What that's going to do is take every instance of a 4 and turn it into a 1. And then a comma, another single quote mark, 16, close the quote mark, equals 1. So that's going to take every instance of a 16 and turn it into a 1. And then another comma, and then we want to say quote mark 0 quote mark equals 0. And that obviously isn't recoding anything. It's saying take all zeros and make them zeros. But recode does want you to tell it what to do with every value that it encounters. And so if you don't have that 0 equals 0 in there, recode will get confused and say, what am I to do with these other numbers that I'm encountering? And so recode does want you to specify every value that it's going to encounter while doing this command. And then you need a right parenthesis to close off the recode command, and another right parenthesis to close off the mutate at command. So we run that, and now if we look at the table for control, we'll see that 254 people have a 0 and 85 people have a 1, which makes more sense than 85 people having a score of 16. And the 1 just means they were in the control condition, and the 0 means they weren't in the control condition. And again, for mixed, we have 77 people have a 1, indicating they were in the mixed condition, and 262 people having a 0, indicating they were not. So the 1s and 0s become presence absence. 1 is, yes, that was my condition. 0 meaning, no, that wasn't. And again, for demcon, we have 92 people with a 1 and 247 with a 0. And for repcon, we have 70 people with a 1 and 269 people with a 0. Now, the next part of the assignment, and the next thing that many people would want to do, is to describe categorical variables, or I'm sorry, not categorical variables, but describe interval or ratio variables, like the age of the sample. And so we're going to use a describe function in a package called psych. So if you've not used psych before, you'll want to use install.packages, parentheses, quote marks, psych, psych, and then load it, library, parentheses, quote marks, psych. And once you do that, you can use the describe function, describe. So describe left paren, and then the name of your data frame. So we're using the deb data, so deb $, and then the variable name, age, AGE here, and then right parenthesis. It's important to note here that you have to type the variable exactly as it appears in your data set. So in some of my data sets, age has a capital A, and in some of my data sets, age has a lowercase a, and you have to be specific about that. You have to use the same capitalization letters, or if you're abbreviating words, or if you have underscores, everything has to be precise. But we run describe age, and it gives us the number of variables, just 1, the number of people who have a score here, 339. This was a variable that I had to impute a lot of missing values because there were almost 30 people in the data set that didn't report their age. So if you haven't watched that video, this is an instance where that's relevant. And then it says the mean age is 21.08 and the standard deviation is 5.46. And in my manuscripts, I typically just report the mean and the standard deviation of the age. And as you can see, this is a student sample, so the average age is only 21 years old. But this describe function gives us a lot more than just the mean and the standard deviation. It gives us the median, which is 20, the trimmed, the mad, I don't know what mad is, the min, the max, the range, the skew, the kurtosis, and the standard error. And so it gives you a lot more than you need for writing a manuscript. And for that reason, I'll show you an alternative later, particularly if getting all of this extra data makes it less pleasant for you to understand what you have or to hear what you have. Okay, now the next thing we're going to do is get the gender distribution of the sample. And I'm going to show you an alt from base R just to get the percentages. So the tabyl function, tabyl, works, and we'll see that there are 117 people who said they were men and 222 people who said they were women. And that's about 35% to about 65%. There was an option for gender non-binary, and there was also an opportunity for people to write in their own gender, but in this data set, everybody that participated in the study identified as either man or woman. Now you can also do prop.tabyl left paren table table left paren and then deb $gender right paren, and that'll give you the percentages. And so again, it shows 1 34.5% to 65.49%. So you can use prop.tabyl if you don't want to use the tabyl table and you don't want to use janitor, but I think for obvious reasons I prefer the janitor table because it gives you the n and the percent, and so it just seems a little more efficient to me. Okay, let's also get religiosity. That was also part of the assignment. So tabyl left paren deb $relig right paren, and so I abbreviated religiosity in the data set as RELIG, and so you have to type it exactly as abbreviated. And the question was, are you a born-again evangelical Christian? And we can see 1 is yes and 2 is no, and 55 people have 1, and that's about 16% of the sample. So about 16% of our sample identify as born-again evangelical Christians, and about 84% of the sample, or 284 people, do not identify as born-again evangelical Christians. Now again, if I were needing to use this in a regression analysis, I would want to turn it into a presence-absence dummy-coded variable. So I would want to take all of those 2's and turn them into 0's. So those 284 people would have a 0, indicating that the born-again identification is not present in their response case. All right, the next item in the lab is to get the mean and the standard deviation for feeling thermometers. And so I'm going to use the describe function from psych that we just used above for age for the Joe Biden's pre-debate feeling thermometer, which is very inconveniently abbreviated lowercase ft underscore capital J capital B lowercase pre. So it's describe left paren deb $ft underscore capital J capital B pre right paren. And again, it gives us the mean, which is 44.57, and the standard deviation, which is 29.1, as well as all of the other data. And then if we do the same describe deb $ft underscore capital D capital T pre right paren, that gives us the feeling thermometer for Donald Trump pre-debate. And here we see that the mean is 31.91 and the standard deviation is 35.26. Now I want to show you a variation in dplyr. I think the code is a little more cumbersome. I don't like it as much as the syntax for describe, but the output has fewer things, which can make it easier, particularly if you're working with something like a screen reader and you don't want the median and the trimmed and the mad and the min and the max and the range and all of that to be showing up for your screen reader. So here, the variation is DEB, which is the name of your data frame. So again, this data frame is called DEB for debate, but yours is probably named something else. So the name of your data frame, and then the pipe, which is the percent sign, the greater than sign, and the percent sign. And then the command is summarize, S-U-M-M-A-R-I-S-E. and then left paren, mean equals mean. And so the first instance of the word mean, M-E-A-N, is labeling the column, and then the equal sign. And the second occurrence of mean, M-E-A-N, is a function in summarize that, or is a function in dplyr that says I want the mean of the thing that follows. And then we do left paren, ft underscore jbpre, right paren, comma. And then after the comma, we can do SD equals SD. Again, this is for standard deviation. So you could type out standard deviation to the left of the equal sign if you wanted. To the right of the equal sign, the SD is the command in dplyr indicating that you want the standard deviation. And again, after the SD, we go left paren, and then the name of the variable, which for us is ft underscore capital J capital B PRE, right paren, comma, and then after the comma, n equals n, left paren, right paren. So there's nothing inside the n paren. And then we have to close out the parenthesis one more time to close out the summarize. And so that last line is n equals n, left paren, right paren, right paren. And if we run that code, it gives us the mean, which is 44.57, the standard deviation, which is 29.1, and the number of people in that variable, which is 339. So the code, I think, is a little bit more cumbersome than simply typing the word describe, but the output is more straightforward. It doesn't give you more of the things than you might want or need. Okay, the 8th task on this lab was to recode the racial resentment variable. So a lot of times in a scale, you'll have some of the questions that have reverse wording, and so the valence of them is reversed, and you need to change the scale points, flip the scale points in order for them to be appropriately used in creating an average. And so in the RR is the racial resentment scale, and RR1, RR3, and RR6 are all three items that are reverse worded. And so what we want in RR1, you'll see that 20 people have a score of 1, and 209 people have a score of 5, 17 people have a score of 2, 69 people have a score of 4, and 24 people have a score of 3. Well, 3s are going to stay 3s, but we want to turn 4s into 2s and 2s into 4s, and we want to turn 5s into 1s and 1s into 5s. And we want to do that for all three of these items, RR1, RR3, and RR6. So how we do that is deb equals deb. Again, this is like saving a Word file over itself. We're just replacing the old debate data set with a new debate data set in which these items are reverse coded. Now, if you're worried that you might be doing the syntax wrong and you're afraid of messing up your data, you can always save the file with a new name. So you could say deb1 instead of deb on the left side of that equal sign. So it could be deb1 equals deb. But I'm pretty confident in this code, so I'm just going to say deb equals deb. And then again, we have a pipe, because again, we're using dplyr here. And then the command is mutate underscore at. So mutate at left paren. And then again, we want to list all of the variables that we're going to recode. So C left paren in quote marks RR underscore 1, close quote marks. And see, you can already tell, like, it's obnoxious having all these underscores. It would be better if it was just RR1. We didn't always have to type the underscores, but what can you do? Then comma, quote mark RR3 quote mark, comma, quote mark RR underscore 6 quote mark, close paren. I'm pretty sure when I said RR3, I left out the underscore. Remember, there's an underscore in all three of those. Anyway, after you close out the paren, you put a comma, and then tilde recode, just as we did above. And then left paren, and again a period, just as we did above, and then a comma, and then again I'm using single quotes here. I repeat, I don't know if that's necessary. So single quote 1, close quote, equals 5. So that's going to turn all the 1s into 5s. Comma, single quote 2 quote equals 4. So that's going to turn all the 2's into 4's, comma, quote 3 equals 3, comma, quote 4 equals 2, comma, quote 5 equals 1. And then close paren on that recode function and close paren on that mutate_at function. So after the quote 5 equal 1, you have 2 right parentheses. And then we run that, and it reverse codes those 3 variables. So now, remember, before when we had table 1, there were 209 people that had a 5 and 20 people that had a 1. Now, there should be 20 people that have a 5 and 209 people that have a 1. And we see that is the case. And if I remember correctly, RR1 is I am mad that racism exists, or something like that. And so these 209 people strongly agreed that they're mad that racism exists, and these 20 people strongly disagreed that they're mad that racism exists. And so since this is a variable measuring racial resentment, we want the not mad about racism to be the high score, and the mad that racism exists to be the low score. Now, the 9th task in this assignment is to get Cronbach's alpha. And we're going to use the Cronbach command in the psy package, psy. So if you haven't used this before, install.packages, left paren, quote marks, psy, close quote, close paren, and then again, library, parentheses, quote marks, psy. The command is Cronbach, Cronbach, and then left paren, and the name of your data set. So for us, that's deb, D-E-B, and then a left bracket, and then we're going to make a list of all the variables in, or of all the items in this variable that we want Cronbach's alpha for. So after the bracket, it's C left paren, quote marks, the double quote marks, RR_1, close quote marks, comma, quote mark RR_2, close quote, comma, quote mark RR_3, close quote, comma, quote mark RR_4, close quote, comma, quote mark RR_5, close quote, comma, quote mark RR_6, close quote. Then we need a right paren, which closes out the list, the C paren, and then we need a right bracket, which closes out the bracket that we started after the name of our data frame, and then we need one more right paren to close out the Cronbach command. So we run that, and it tells us sample size is 339, the number of items is 6, so that's the 6 items that are RR1 through RR6. And then it tells us that the alpha is 0.8971, which is good. That's a nice, reliable variable right there. Well done, us. Okay, the 10th and final task in this assignment is to describe the racial resentment variable. And in order to describe it, we have to compute the variable, which means we need to get the average of the 6 items. So to do that, we're going to create a new variable that I'm just going to call RR, but you can call it whatever you want. So I'm going to say deb $RR, that's going to be our new variable. RR is the name, deb is the data set, so whatever your data frame is, that's what you use. We're saying create this object, RR, and put it inside this data set, deb. So deb $RR equals left paren, deb $RR_1 plus deb $RR_2 plus deb $RR_3 plus deb $RR_4 plus deb $RR_5 plus deb $RR_6, right paren to close out all of the items in the variable, and then divide by 6. And we're dividing by 6 because there are 6 items in the variable. So however many items are in your variable, that's what you divide by. So we do that, it computes the variable. Now we can use the describe function to get the mean and the standard deviation and all the other stuff for the racial resentment variable. And so that would just be describe left paren deb $RR right paren. And that gives us vars 1 and 339, mean 1.99, standard deviation 1.01, and then it gives us all the other stuff as well. And again, if we want to use the alt in dplyr, we can do deb pipe summarize left paren mean equals mean left paren RR right paren comma SD equals SD left paren RR right paren comma N equals N left paren right paren right paren. And we run that and it gives us again the same mean. The mean is 1.989, the standard deviation is 1.005, and the N is 339. That is everything that you should need to know how to do for the method section of a manuscript. That is everything that I've assigned in my Quant 2 lab this year, Quant 2 Lab 2. And the last thing I'll say is now that we've done recoding the racial resentment variable, recoding the experimental conditions, computing the racial resentment variable, I think it's worth saving a copy of this data set into our working directory. So I'm going to use write.csv left paren deb comma left quote mark capital DEB underscore capital LAB2 underscore capital FEB6 dot CSV right quote right paren. So what does that do? It writes a CSV file. It uses the deb dataset, which is the data that we've been working with this whole time, to create the CSV file. So that's why it's deb comma. And then in the quote marks, I'm creating the name of the file that I want it to save. So I'm saving it as deb to remind me that it's the debate data, underscore lab2 to remind me that I did all of this work in lab 2, and then underscore feb6 to remind me that I did all of this on February 6th. And then I have to put .csv at the end so it saves it as the right file type. So I run that, and it saves that file into my working directory. If you don't save a copy of the data that you just did in your working directory, the next time you load the data, it'll be without any of the transformations that we've done here. And so you'd have to reverse code the racial resentment items again, you'll have to recompute the racial resentment variable again, and you'll have to fix the experimental conditions again. So that is why I put that at the end. If you're in my class, I'll make this syntax available as well. If you're just watching the YouTube video, I hope that you found it helpful and that it assists you as you use R in your data preparation. Thanks for watching. I'm always open to comments for new video ideas. I appreciate any comments that I do receive, even if I'm somewhat slow in answering or replying to them. Have a great one.